Now children, let's recall the property of intercepts made by three parallel lines. Looking into the figure at the board, we know which are the three parallel lines shown to us. That is L, M and N. Then which are the intercepts? Which sides will be called as the intercepts? Those are AB, BC, DE and EF. Those parts of two transversals cutting the three parallel lines, those intersected parts are called as intercepts. And what is the property of intercepts made by these three parallel lines? It states that the ratio of the intercepts made by two transversals, irrespective children, the transversals can be parallel or as you can see they are non-parallel. Then what is the property? Then it says that the ratio of the intercepts, that is AB upon BC. So ratio of intercepts made by two transversals are always equal. That means AB upon BC, the intercepts formed by the first transversal, their ratio is always equal to the ratio of the intercepts made by the other transversal. Which is the other transversal over here? T2. Which are the intercepts formed? They are DE upon EF. So once again, to recall, what is the property of intercepts made by three parallel lines? It is the ratio of the intercepts made by three parallel lines on any n number of transversals is always equal. So AB upon BC is always equal to DE upon EF, and you can see that ratio is always a numerical constant, say M upon N. So let's use this to understand the section formula. Now what is the section formula, children? As we can see in the diagram, again a segment is drawn. Which is that segment? AB. What is observed in that diagram? That we have coordinates of AB as x1, y1, x2, y2. Then how do we calculate the coordinates of point P, who divides segment AB in any ratio? So let's see how do we move on with the section formula. Again children, let's take the base of property of intercepts made by three parallel lines to understand how to derive the section formula. For this, let's draw three perpendiculars from point A, B and P towards your x-axis. This is one. From P, again drop another perpendicular. This is the second one. And the third one from point B. This is the third one. So I have marked that they are three parallel lines cutting the x-axis with an angle of 90 degrees. From point A, from point P and from point P. Let the intersection points be C, D and E, where they cut your x-axis. Now children, how do we calculate? Let's find out the coordinates of C, D and E. If we compare C with A, both are, when you join, parallel to your y-axis. So, what will be the coordinates of point C? The x-coordinate remains the same, that is x1. And as the point is lying on the x-axis, the y-coordinate is 0. Let's proceed to find the coordinates of D. Again, D is lying on x-axis, so its y-coordinate is 0. And what about the x-coordinate? The x-coordinate is the same as the coordinate given to P, that is x. let's proceed to write the coordinates of point E. Again, E is lying on x-axis, so the y-coordinate is 0 and the x-coordinate will be the same as the coordinate of B, that is x2. Now children, let's use the property of intercepts made by three parallel lines. Which are the parallel lines drawn over here? They are AC, parallel to PD, parallel to BE. And we have two transversals. Which are the two transversals over here? AB, if you extend, and the other transversal is your x-axis itself. So how can we apply property of intercepts made by three parallel lines? That means AP upon PB. Therefore, AP upon PB will be equal to CD upon DE. How did we get this? By using the property of intercepts. Made by three parallel lines. Now children, let's talk in terms of distance. If we see how much is CD, can we calculate? How much is D, can we calculate? Let's begin. Now CD, both the points are lying on the x-axis. So let's calculate CD upon DE. How much is CD? It will be the difference between the x coordinates, that is x minus x1 upon, what is the distance between DE? Again, as they are lying on x-axis, y coordinate is 0. So we just take the difference between the x coordinates, x2 minus x. And that is always equal to the ratio of the intercepts. So let's take it as m is to n. The ratio of the intercepts as m is to n. So children, now let's concentrate and solve this part. What do we do when you have this? We always cross multiply. So n into x minus x1, which is equal to m into x2 minus x1. So children, let's open the bracket. So we have n into x, that is nx, minus n into x1, that is nx1, which is equal to, here children, it is m into x2 minus x. So m into x2, mx2 minus m into x with a minus sign. So minus into plus gives you minus, and m into x gives you mx. Okay. Take all the like terms together, that is x terms together. So what happens to minus x? We take it towards the left hand side of the equality sign. So minus becomes plus. So mx plus mx will be equal to mx2 minus x1 goes from the left hand side towards the right hand side. So that is plus nx1. Let's proceed, children. To get the section formula. So what do we have? We have nx plus mx, which is equal to mx2 plus nx1. What is common on the left hand side? We see that x is common. Inside the bracket, you have n plus m, which also can be sequentially written in the alphabetical order as m plus n, which is equal to mx2 plus nx1. These are unlike terms, so they remain as it is. we are calculating the value of x. So, the term m plus n, the binomial, is performing multiplication. When it goes on the other side, division. So, x will be equal to, finally, mx2 plus mx1 upon m plus n. This gives us the value of x coordinate of point P, which divides the given side or segment into two parts as a ratio of m is to n. Then what about the y coordinate? How do we get the answer for the y coordinate? The answer is easy, children. The same logic implies to calculate the value of y. For this, what do? Drop perpendiculars from point A, from point P, from point B towards now your y-axis. And once again, when any point is lying on the y-axis, its x-coordinate remains 0. The ratio, again, we imply properties of intercepts of three parallel lines. And once we are done with, how will we get y? Y will be equal to my2 plus my1 upon m plus n. So, how do we conclude? We get the coordinates of x and y. For which point? For point P, dividing line AB or segment AB in the ratio of m is to n. So this is called as section formula, which we will be using in problems to find out the value of unknown, whether we have to calculate the value of the ratio or the value of any unknown variable over here, that is the coordinate of B or coordinate of P or coordinate of A. So children, what is section formula? It gives you the answer for the coordinates of point P, which is dividing segment AB into two parts. And the ratio can be said as m is to n. So x coordinate we get by using the formula mx2 plus mx1 upon m plus n. Y is equal to my2 plus my1 upon n plus n. What is m and n? M and n stands for the ratio that point P divides AB into. What is x1, x2, y1 and y2? They are the coordinates of the end points of that given segment.